Okay, so in this short video, we are going to learn about carbon, and we're spending some time on this year. So just go ahead and write that title down. And I just want to point a few things out to you here. First off, carbon is located right where this big arrow is here on this periodic table. Now, we've learned quite a bit about oxygen right here. We've learned about hydrogen. We've even talked about sodium and chlorine. There's chlorine right there, sodium over here. So we've learned about those things, okay? But we're going to be learning about carbon now. And as you can see right here, its atomic number is 6. Now, just for quick review here, atomic number 6 means it has 6 protons. Remember, those are the positively charged particles that are found in the nucleus, all right? Down here is the atomic mass. Remember what the atomic mass is. It's the protons plus the neutrons. Okay, so we have 12. So if we take this atomic mass, which is 12, we subtract out the protons, which you know they're 6, what we'll get is the number of neutrons, which you know is also 6. Okay, so we know in this nucleus there are 6 neutrons. Remember, those are neutral. They have no charge. And because this is an atom and it's not an ion, okay, so it has no charge to it, we also know that for every positive proton, there is a negative electron. So there are 6 electrons in carbon as well. Okay, so just some things to keep in mind as we dive into this. Now, let's draw a picture here of carbon and some of the things that it does. So we're going to start here. I'm going to put a C that's going to represent our nucleus. Remember, 6 protons in that nucleus and 6 neutral neutrons in that nucleus. And I'll draw a circle here just to kind of show, okay, that's where the nucleus is. We have 6 electrons. You guys remember from before that the first electron shell can hold 2 of those 6, and the next one can hold up to 8. But we only have 4 left because we already used up 2. And the electrons like to be nice and spread out. So that's how the 6 electrons get placed around carbon. Now, remember why atoms do reactions. To get their outermost shell filled. They'll share electrons, they'll give them away, they'll accept them. Well, here, carbon has 4. So it needs 4 more. It's not going to give away those 4. Okay, that's just not something that's going to happen. So what carbon will do is it will do covalent bonds with 4 other things. And carbon can do covalent bonds with numerous other molecules. It can do it with hydrogens, oxygens, other carbons, nitrogens, anything that would really want to do a covalent sharing electron kind of bond, carbon will do it with that atom. Okay? So, and this is very important that you understand this. So, I don't know, let me show you the simplest carbon compound. You guys remember hydrogen? Hydrogen has 1 proton, no neutrons, and it has 1 electron orbiting it. Remember, since it only has 1 shell, it would like to have 2 electrons. So what hydrogen does is it will share with carbon, and 4 hydrogens will do that. And this is the smallest, or maybe even the simplest carbon compound. It's called methane. Okay, and as you look, carbon feels like it has 8 electrons. It has its own 4, plus the 4 that are being shared with those 4 hydrogens. Carbon is done reacting there. So this would be called CH4, and that's called methane. The hydrogens are all happy because they have their own 1 electron. And then the ones that orbit carbon spend some time close to them, so they feel like they have 2. So that would be how carbon does this. So remember, where I have those H's on there, we're going to see that carbon can connect to lots of other atoms, like I had already talked about. Okay, so I would write that down, but I'm going to erase it right now, so pause this if you need to. And here's some general characteristics. So we already said that, but jot that down. 6th element on the periodic table, which means its atomic number is 6, which means 6 protons. Okay? And carbon happens to have 6 neutrons and 6 electrons. Carbon, let me get this out of the way here. Carbon can form covalent bonds to 4 other atoms at the same time. That's what simultaneously means. Carbon can also form bonds to other carbons. And any molecule that contains carbon is called an organic molecule. So write down all of these statements here. When you go to the grocery store, the word organic means something a little bit different. Okay, when you go to the grocery store, And if you're taking a look at the food, the organic food typically costs a little bit more. And what organic means in the grocery store is that there were no pesticides used to kill bugs on the plants. There was no artificial fertilizers applied or anything like that. And that's what organic typically means. That's not what it means in chemistry. Okay? In chemistry, organic means containing carbon. Guys, all food contains carbon. So from a scientific or from a chemistry point of view, all food would be called organic. Okay? But that's a slightly different definition, I guess, when you're at the grocery store. All right. Couple vocab words you need to get down here. Carbon is the backbone of these different macromolecules. Now, you guys have already started or you're going to start researching some of these. And remember macro invertebrates. Macro means large. And we know what molecules are. So yeah, these are going to be large molecules. Okay? Now, they're still microscopic, but a macromolecule would be like DNA. That's a large molecule. Or maybe something like, if you've ever heard of like a polysaccharide, a large sugar. Those are macromolecules. Proteins are macromolecules. Okay? Something that would not be a macromolecule would be like carbon dioxide. That's a small molecule. That's just, you don't call that macro. H2O, that's a small molecule. So those are not macros. Okay? So write down the definition of macromolecule. Okay, and these biological macromolecules, some books may just call them organic molecules, and that's fine too. A monomer. Now, guys, remember your prefixes. Mono means one. A monomer is a building block, a single unit that many of them can get put together to make something larger. Almost think like playing with building Legos. Okay, each little Lego brick would be like a monomer. You put them together and make something much larger. And the much larger thing is called a polymer or polymer. You probably heard that word before. But a polymer, poly means many. So a polymer is made of many monomers put together. And I know I'm not giving you a lot of examples right now, but as we start going through class over the next few days, you're going to have so many examples of this, plus that chart that you're going to fill in. You're going to have monomers and polymers in that. So that's what we're talking about here with monomers and polymers. Okay, so again, pause this if you need to, guys. Okay. The 4 carbon compounds that we are studying are carbohydrates, lipids, nucleic acids, and proteins. Okay? I don't know if you really need to write this down because you're going to get this as we go through things here. But carbohydrates, the simpler word for that is just sugars. Lipids would be those non-polar hydrophobic things we were talking about, like fats, oils, waxes, things that water cannot dissolve or adhere to. Nucleic acids would be your DNA and your RNA. And I know you've all heard of DNA. RNA is very closely related, and you'll be an expert on that later this year. And then we'll spend some time talking about proteins. It's very important that you understand what those are. Okay? These are all macromolecules made of carbon, oxygen, hydrogen, phosphorus, and nitrogen. And again, I don't think you need to write that down because you're going to see that in that macromolecule chart that you're working on. Okay. We're talking a lot about chemical reactions as we start doing this this new work here, okay? There's a few basics that I do need you to know about chemical reactions, okay? So if you take a look up here, I have, let me see for a second. Yeah. Here we have carbon dioxide plus water, and there's an arrow going to this thing they're calling organic matter plus oxygen. I need you to know a few things when you look at a chemical reaction, okay? So go ahead and write out this chemical reaction. And honestly, we can get rid of these. They're called coefficients because I don't want that to be what you're focusing on. To the left of the arrow, so the carbon dioxide and the H2O, those are called reactants. They're what goes into the chemical reaction, and they're going to go through the reaction. So they're called reactants. Okay? Once the reaction occurs, what gets produced, almost like multiplication, you have products and multiplication. What gets produced are the products. Okay, and this is actually called glucose. That's your blood sugar. So we have glucose and some oxygen. Okay, this is actually the chemical reaction for photosynthesis. So plants make that same sugar called glucose by using the sun's energy. Now, one more thing, you notice there's not an equal sign in the middle of this thing. And the reason why is carbon dioxide and water are not equal to glucose and oxygen. That makes no sense. They're not the same thing. They're not equal. They might have the same atoms, but they're not equal to one another. So that's why we have an arrow right here. The arrow does not mean equals to, it means yields. If you don't like the word yields, maybe if you want to think produces. So carbon dioxide and water can yield or produce glucose and oxygen under certain circumstances. And also, in a chemical reaction, if you ever need any type of energy, you typically write that above the arrow. So here they just drew a sun. We would write the word light above the arrow. Okay, energy is not made of carbons and oxygens and hydrogens. It does not matter. So that's why we don't put it over on the left. Okay, so you wouldn't put light over as a reactant. It's not the same thing. It's not matter. It's energy. So we write it over the arrow. Okay, guys, and just take a minute just to kind of make sure you have those things noted. And like I said, we're going to be using this an awful lot, so you'll have lots of practice with these words and where things go and that sort of thing. All right, now you're doing a chart very similar to this, so we're not going to look at this right this minute. Okay, now we're going to start looking at some, now not today, but over the next few days, some of these molecular, I guess, drawings of how these things are represented, okay? So let me write down these 2 pointers here. So how to read molecular compounds. Let me give you an example. Sometimes you're going to see a compound that looks like this. Okay, I'll just leave that alone. And you might think, oh my goodness, what the heck is this? All right. First off, that O is an oxygen. And what this step 1 says is wherever lines intersect, there is a carbon atom at the intersection. Okay, so here's an intersection. There's a C. There's a C. Chemists don't like to write these in. I don't know if it makes the diagrams look too busy or what. But every time lines intersect, you need to understand there's a carbon sitting there. Sometimes you'll even see it looks like this. We'll see different compounds that look like this. And you're like, okay, well, every time lines intersect, there's a carbon there. Okay, this would be connected off to something bigger. That's what step 1 really means. Step 2, or pointer number 2, okay? Carbon always makes covalent bonds to 4 other atoms. It has to. It will keep grabbing hydrogens to make sure it has 4. Okay? Well, if we take a look up here, let's look at this carbon. It only has 2 bonds, one right here and one right here. But I said carbon always has to make 4. So where are the other 2 at? Anytime they show a carbon that does not have 4 bonds going to it, you need to know that anything else is hydrogens. So really what's going on with this is there would be a hydrogen connected to that carbon and another one. That way the carbon has 1, 2, 3, 4 bonds to it. Same thing with this one down here. We only see 2, so we need to understand that it would also be doing covalent bonds with some hydrogens. Okay? Over here on this one on the left, this carbon, we're only seeing 1, 2 bonds going to it. That's all they're going to show you. They need you to understand that, yes, anything we're not showing you is hydrogens. So every C must have 4 lines coming out of it. If they're not showing you 4 lines, you understand what they're not showing you is hydrogens. Over here with this carbon, you only see 1 bond. So then there would be 3 hydrogens covalently bonded. Okay? I know it's a little bit out of context, but as we start looking at some of these things, those 2 tips will help you to not be confused. Okay. So guys, that is the end of this video. Please go back and rewatch anything, and please make sure that you have taken notes on this. And we'll be getting more and more into this over the coming school days here.